Okay, welcome back. This is video 3. We're going to be doing movement and jumping with the character. We've done this before in previous videos, but I'm just going to do it again here, but using the new input system. Everything else is going to remain the same except for the way we get input. So let's go back to our input here, and I'm going to go to my buttons. I've got the buttons I need. I need to go to movement. So I've got move. I need to add a new one. And this one needs to be look, I guess. And I'm just going to make sure that these are set correctly. So this is going to be a value of vector 2. And in here, we're going to be using our, sorry about this, there we go. We're going to be using our right analog stick. And if we add another binding, this one's going to be our mouse. So we're going to go mouse, delta. So we're getting the delta movement of the mouse, and we're getting the right analog stick. And this is going to drive our camera look. So this is for movement, this is for look. So on the movement, I use the left analog stick of my gamepad as soon as it catches up. And the keyboard, your standard first-person controls and standard first-person controls for looking around. Okay, so now that that's done, I can just close that for the time being. Go into my flow graph, and we're going to delete everything that we have here. But that was just for testing. Okay, I'm going to maximize this window so we have it. Okay, so at the start, we're going to leave this because we do need that to be there. So we're going to add, let's call this speed multiplier. So this is going to be the speed of the player. It's going to be a float. And I'm not quite sure. I'm just going to quickly base it on what my speed is in my project that I set up for testing. It says about 250, so we're going to make it about 250. And the next one is going to be our camera sensitivity. You always want to add camera sensitivity because not everyone plays with the same kind of sensitivity value. So depends on how you want it. I'm going to make mine about 150. I think I'm probably going to have to tweak that. But there's my character speed. That's my camera sensitivity. These are all in the object so that I can access it from outside of this script. The next one I'm going to add is grounded. So this is going to check to see if I'm on the ground or if I'm not. It's going to be a Boolean. So we can see whether we can jump or not. That is the idea. Okay, so let's go back to object, and we're going to need one more variable, and this is going to be for the camera reference. So we need a reference to the camera. It's going to be a transform because we're going to be doing things to the camera. I'm going to click over here and select the camera from the list because it is there. There we go. That is good. That is done. And all we need to do is, I'm going to be using a rigid body to drive this character. So I'm going to need to get the input in the update and the movement in the fixed update. So before we even do that, I need to add a rigid body. So I'm going to add a rigid body to this character, and I'm just going to move it up. Just put it under the capsule collider. I'm going to give this character a weight of about like a human person's weight. I'm going to say about 70 kilograms. I'm not sure how many pounds that is, so I'm just trying to make the mass accurate. I'm going to change this to continuous so that we get decent calculation for weather or physics. If the character starts to move too quickly, we don't want it to fall through the floor or go through objects. Okay, so I'm just double checking that I am correct with everything that I have. Yep, okay, so that's all we need on the character. We have a collider, block him from going through things. We have a rigid body to make sure that we can add force and all that sorts of stuff to it. So let's go back into our script. So we're going to have an update and a fixed update. Come on. Not fixed joint. Go back. Fixed update. Okay, again, like I said, in the update, all we're going to be doing is getting the inputs and doing all the speed multipliers and all that stuff. And in the fixed update, we're going to be doing the actual movement. Because we're using physics, physics is more reliable if it's done inside of the fixed update, whereas if it's If it's non-physics stuff, you can do it directly in the update. Okay, we're going to start with your standard movement input. We're going to get it, and we're going to store that movement. So we don't have a variable for this, actually, and I like to keep my variables nice and clean. So I normally create a, let's just call this, let's call this move input. And I normally make it a vector2 just to keep things nice and neat. So vector2 can store two pieces of information. So X is going to be my side-to-side movement, and Y is going to be my forward and backwards. And I'm going to do another one called look input. And it's also going to be a vector2, and it's going to hold my side-to-side rotation and my up and down rotation. So it just keeps it nice and neat. I could create 4 variables, 4 floats, but just having 2 variables here that contain 2 pieces of information just makes it neater. Or at least for me, it feels like it makes it neater. Okay, so from the update, let's just move the fixed update down here. From the update, we are going to first have to drag this move in and this look in as a set variable. Remember, when you hold down Alt and drag a variable in, you get a set. If you just drag them in, you get a get. Getting information and setting information. Whenever you're in doubt, it's a simple thing to remember that you're getting and setting stuff. Okay, so there we go. There is our 2 variables that are going to store the inputs. And remember what we did earlier on? We grabbed a new input here. We drag it out. We type in new input interface. We expose it. We could do whatever we want. On button down, on button up. In this case, we don't need the whole thing. We're just going to get the vector2 inputs here. We're just getting the vector inputs because that's what we need. Okay, so what we need to get 2 different ones. We need to get the move and the look. So from here, we're going to type in get item. We're going to get dictionary item. I'm going to duplicate this and plug this one into there, so we're getting both of those inputs. Remember, we're looking for a string by name, so here it's going to be move, I think. We'll double check it now, and this one is going to be look. So, and then these will go into their appropriate inputs. But before we do that, let me just delete this fixed update. We'll come back to that. We want to normalize this value. We want to make sure that this value that comes out of here does not exceed 1 or -1. So we're going to just normalize. When in doubt and you're not sure what normalize you want to use, just use the generic normalize. The Bolt will figure it out. But because we know this is a vector2, if I were to type normalize, I'd probably use a normalize vector2. But again, Bolt is smart enough to kind of get what you're trying to say. So if you're not 100% sure, just use a standard generic from your C# class and you should be fine. Okay, there we go. So normalizing will allow me to normalize those values so that I don't get any inconsistent values. The reason we're normalizing this is just so that we get reliable results every time. Okay, so I'm going to move this down a little bit, and we're going to drag in our camera sensitivity and our speed multiplier. And all we're going to be doing here is we're going to be multiplying this value by that, and then we're going to plug that into the movement. Oh, sorry, trying to make that nice and straight. And we'll move these up and do the same thing. So I'm just going to duplicate that, plug that into this A, this into the B for the camera sensitivity. Notice how I'm doing the movement for the multiplier and the look to these camera sensitivity. And then I'm going to plug that into there. Okay, so this is essentially how we're going to get our input and store our input every frame. So I'm going to put a comment group around this. Oops. Okay, change this to red. Red just to remind me that this is an update. It happens every single frame. So I can start looking. I kind of create myself a little legend just so I can keep track of what's on an update, what gets called when you summon it, if you will. So there we go. That's it. So I'm going to move this again. When you're working with visual scripting, you got to find the best way to make this not look like completely spaghetti coded and look very messy. I like to I spend a lot of time making sure it reads properly. Okay, so there we go. Input. This one is called store player input for movement. Okay, so we're storing the player movement there, and we're also going to want to just update the animator while we're here. So I'm going to need a new variable for the animator. It's going to be of type animator as well, and I'm going to click on the circle here and find the character that's got the animator. I'm going to drag this variable in, and here we remember this is why we did all the work beforehand. So from here we're going to type in animator dot set float. I think the first one was called forward. I think. I'm trying to remember now. I'm quite sure it is. I'm going to, again, just select these two, duplicate them, move them across. And this one is going to be right. Okay, so where are we getting these values from? Very simple, from our input here. So I'm going to drag in my input variable as a get. And I'm going to get vector2.y for the forward, and vector2.x for the right. And that's it. That's how we're going to update our animation in the animator based on these inputs. So we can test this already. There's going to be no movement, but the animations will at least play. So we're just going to put a comment group around this. Call this one update animator movement state. Also make it red because it is going to be updating every frame. You can also color code it based on what it does. That's up to you, how you want to color code this. Okay, so let's test if what this is doing it, if that makes any sense. So I'm going to press play. The character should go into an idle pose. There we go. I'll press forward, right, left. Mine are currently the other way around. Interesting. Might have plugged them in the wrong way around. So there we go. So you can see the animations are working. My code is not set up correctly. Let's see. X, Y should be forward. It makes sense to me. And right should be right. So let me just go and make sure my animator is set up correctly. Forward. Now forward is... Let's just switch these around. Let's just see. I might have set this up a little bit wonky. Makes no difference. It really doesn't. How you see this graph is up to you. Y is normally up and down, the X is side to side, but okay, there we go. We'll leave it for now like that. We'll probably have to come back to it, but there we go. So now the animations are working. So all we need to do is actually get the character moving, which it isn't right now. So we've got all the inputs. Now we need to go down here and actually do the movement. So we're going to start by doing the movement, then we're going to start do the rotation of the player, then the rotation of the camera. I like to keep them separately. So what I mean by that is I'm going to rotate the player from side to side on the actual player, and the camera is only going to be rotating in the x-axis, so up and down. That way we don't get any gimbal locks or weird transforms or anything like that. So I'm going to create a prefab folder really quickly because I want to make sure I prefabs, and I'm going to drag the player. I'm going to rename this to controller. So FPS controller. I'm going to drag the FPS controller into the prefab folder so we have a backup of this somewhere in the project that isn't just inside of the scene somewhere. Okay, so let's get moving. We're going to go into the fixed update and do the remaining logic that's needed. From here, we are going to drag it out and type in rigid body dot velocity set. So we're going to set the velocity based on the inputs that we have. So if there's no input, there's no velocity, that kind of thing. Now, we can't just plug it directly. It's all compressed into one file. So we need to drag out and create a new vector3 x, y, z. So we can get each of the vectors separately. And we also need our movement variable out, drag it out. And we're going to need to break it into the x and into the y. So we're going to go v2.x. We're going to go v2.y. So we have the x and the y separately again. And we now are going to be multiplying this by time.fixed delta time so that we get a consistent frame rate. So we're going to multiply, duplicate this multiply and plug it down here. And both of these need to be controlled so that we don't get any weird frame rate issues if the PC frame rate drops on the movement itself. So we're going to go add unit time.fixed delta time. We're going to multiply both of these values by a fixed delta time. So remember, we didn't multiply it in the input up here. Okay, there we go. So now we've multiplied both of these by the frame rate. All that's left to do is take into consideration the the characters forward and the characters right, not world forward and world right. So we need to grab both of these values. We need to multiply this value again and duplicate this one and multiply this value. And what are we multiplying them by? Depending on what we're doing. So this one we're going to multiply by the forward of the character. So we're going to go transform dot forward. And this one, as you guessed, transform dot right. I'm hoping that the video's quality, audio quality is better. I have been spending some time tweaking it. It's probably not going to be brilliant because I'm working with what I have as far as the quality of the microphones and that kind of thing. So I hope the audio is better now than it was in the last couple of videos. I felt like the audio was getting better with the videos. It just depends on whether I'm doing it on my laptop or my PC. So there we go. I'm multiplying my X by my right, so my side to side, and my Y by my forward. So that is what we're doing here. So all we need to do here now is combine these two together. So we're going to go add, them together. Sorry, let's just do a proper add. Let's not be lazy. There we go. Add vector3. After we've combined all of these together, and we're just going to put a comment group around this, call this add layer input based on the player direction. That's what we want to do. And this is not, it's not going to be, I want to make it kind of orange. Orange suggesting that it fires intermittently because it is on a fixed update. So I'm just making this orange. Okay, so now that we have this, we need to split this out again and put them in the appropriate sections. So this one is going to be, we need to get a v3.x. We need to get a v3.z for the side movement. And we're going to plug the x into the x, the z into the z, and the y is simple enough. The y we're getting from the velocity, the rigid body. So we're going to go rigid, sorry about that, rigid body dot velocity, get. And from here, we're going to go v3.y because we need the up and down movement to be using gravity. There we go. That should do it. That should be all the inputs. That's now adding velocity based on inputs. Okay, so I'm going to put a comment group around this whole thing. Let's call this player movement. There we go. So this is controls the player movement. We can even test this right now to see if it works. So I'm going to go here just so you can see it working. I think I should grab this floor and I'm just going to add a, go to my mesh renderer, go to my materials and just add a, I'm going to type in the word checkered. Okay. I think I need to make a checkered floor material. So I'm going to go here, create a new material, call it checkers. I'm going to assign this material to the floor here, and I'm going to assign the texture called checker default. You can get some really nice ones. This is just very boring and dull, but just for this case, I'll go grab others, and I'm going to tile this a few more times. I think 20 by 20 is good, so I can see the character moving along this grid. Okay, so let's see what happens. We will have no rotation, be aware of that. We can only move forward and backwards. So let me see, forward, backwards, forward, backwards. Okay, so what happened? I forgot something on my rigid body, which is always good to forget so that you can remind yourself how. So let's go to the rigid body, open up the constraints, and I'm going to freeze all of the rotations. So my character cannot rotate unless I tell it to rotate. Okay, so let's try that again. There we go. Back, forward, left, right. All of this is working. You can see it working in the background. Feels quite nice already. I think the movement might be matching the run cycle quite nicely. There we go. Okay, so that's working. So now that we have input, now we need to do a rotation. So all of our input is done. The next stage is to do the Y rotation, or I think it's called your rotation. Yeah, I think it is. So let's do that. So I like to do this with a rotate. It's weird. I use two different ways of doing the same thing. I just find that this the rotate's really nice because it does what it says. It rotates. So transform.rotate. I want to say Euler angles is good. There we go. So this is going to rotate along the Y. So looking side to side. Sorry about that, my throat. Okay, so now all we need to do is we need to get the transform.up. Because we're going to be rotating around the up vector. Now we are going to be multiplying this. We're going to plug the result into the rotate, like that. Like I said, I've done this in previous videos. I'm just doing it again so you don't have to go looking for that other video that I had. I'm going to multiply this again one more time. And we're going to multiply this by our look input. There we go. And for this case, we are looking for our X movement, side to side. So vector2.x. Make myself some more room here. Like this here. Okay, so what are we multiplying it by? We're multiplying it again by time.fixed delta time. So time.fixed delta time. There we go. And now this should control our side-to-side rotation movement. That's it. It's that simple for the Y rotation. Just going to grab this here, copy this color, paste. And let's call this Y rotation. Let's call it player Y rotation. Okay, so all that's left to do now is rotate the camera up and down. So let's test to see if this works. Again, you just want to make sure that these kind of things do work as you're doing it. You don't want to be faced with an issue where you've done all of this coding, you haven't actually tested anything, and then notice how my character can now look side to side. So if I look that way and I run, my animation should be playing relative to the direction of the character. There we go. Done. So that's working really nicely. So now we go back in here, we do the last section, which is the camera itself. Okay. So before we can do any of that, I'm going to create a variable in the object called X rotation clamp. X rotation clamped. It's going to be a float. So I want my character to only be able to clamp its rotation in a specific amount. So I want the character to only be able to rotate down and up to a certain amount, not more. So this is going to store that value, and then we need another one which is going to be in the object. call this clamp values. Let's call this camera X clamp values. There we go. I'm also going to move this up a little bit. I think it should be near the other important values, like at the top here. It's going to be a vector 2. So minimum, like the negative value and the positive value of the clamp values that we want to use. So in this case, let's make mine, I don't know, let's make it minus 50 degrees and minus 50 degrees and positive 50, let's just say. Actually, let's just make it 60 and 60, minus 60. Minus 60, let's try that again. There we go. So we have these clamp values. Okay, so we need to start by clamping the values. So we're going to grab the clamp values, drag it in, go back to our graph, hold down Alt and drag in the X rotation clamp value, and plug it in there. Now we're working with rotations is really tricky. So before I even rotate the camera, I make sure I add the required amount of values, clamp that value, then feed it into in this case, because I hate using rotation, I'm going to use a transform.Euler angle. Euler angles allows me to work with vectors. It's a lot easier and it makes a lot more sense as far as degrees go, whereas the others don't. So this is going to be rotating the camera. Where's the camera? I'm hovering over the wrong thing. Camera reference. I'm going to grab the camera. We're not rotating the player, we're going to rotate the camera. Rotate the player is going to do this kind of weird tilting rotation thing. So we're going to be rotating the camera for the X. And again, we need to split this out because we are going to be using all of the values except for the X from the current player. So let's just do that now, actually. I'm going to do a transform.Euler get. So I'm getting the player's rotational values, and I'm saying, in this case, it's a vector 3 dot get the Y and get the Z. I don't actually ever want to rotate along the Z axis. It will create some weird results. So I just bring it anyway because we're not actually doing any rotation along the Z. Except for when we do the wall run, that's when we rotate the camera. There we go. So these are getting the rotation from the current player. Feeds it back in. Actually, I don't think it shouldn't be coming from here. It should really be coming from the camera. Block that. Because we are updating the camera. So there we go. Last thing to do is grab the clamped value and plug that into the X. Now, this section of the code is pretty much done. All that's left to do is actually do the calculation aspect of it. Give myself some room here. It's getting a little bit tight. Okay, so on this side here, what are we going to do? We're going to do a mathf.clamp on this side here. So we're going to go mathf.clamp. And we're looking for a value. We're looking for a float. Try a minimum float. This is an integer, so we're going to grab the float. What is the value that we're clamping? What is the minimum and the maximum value? We have this. The minimum and maximum, we just created this camera X clamp value, so we're going to drag that in. We're going to go vector2.x, vector2.y. If you're wondering why, it's because this clamp value is a vector. So X is going to be our minimum value, and our Y is going to be our maximum value. That is how much we can clamp. This is how far the rotation will go before it stops rotating any further. So, actually I didn't need that. I don't know why I dragged that in again. Okay, so we're going to drag in our X rotation clamp value. I'm going to drag out and I'm going to add. I'm going to plug that into there. What are we adding? We're adding a few things. So we're going to use a multiply here. If you're wondering what we're multiplying, you will see soon enough. We're going to be multiplying the look input dot y. So we need to grab our look input. Vector2.y. Remember, y is the up and down of our input. So the mouse going away and towards the player. So we're going to multiply that value. And again, before we do anything else, we're going to be multiplying that by time.fixed delta time, as you probably get. When in doubt, you're not sure whether to use fixed delta time, just use it anyway. You can't go wrong with it. I when I first started out, I never used it. I was like, I can't see the reason for it until I did a build of the game where it was running nothing else but this, and I saw the performance. I saw that my character was running faster because the frame rate got better, and I had spent the whole time in the editor doing it this way, and it felt wrong. The movements were all wrong and everything. Okay, so we have an issue here, and I want to create a variable that will control that. Not everyone plays the game a certain way. So if you like your inverted controls or not, I'm going to create a variable here called invert camera control. I'm going to make that an integer, and mine is going to be -1. So what we're going to do is we're exposing this variable so that we can then use it in, like, for example, we can use it in the menu or something to choose. So I want my controls to be inverted because I want up to be up and down to be down when I move the cursor away, move the controls away and towards me. So that is why I want my controls to have a negative value. You can put yours positive, that is up to you. Okay, that should do it. So this is player camera X rotation clamped, just so we know it is a clamped value. Okay, let's see. Let me just clean this up a little bit. As it gets further along, it's going to get a little messier. We're just trying to keep it as neat and as clean as possible before it truly gets out of control. You can make super units for this just to keep things nice and neat. It's up to you. Just keeping it all over here so it's easier to find everything when I need it again. Okay, I hope this series is helping. We're gonna, at the end of this, if we have a little bit of time, I'd like to try some multiplayer stuff. So I think it would be a lot of fun if we can do that. Okay, so let's see how this looks. I want to see what our camera sensitivity variable is. 150. I think 175. The other one was a little. You could create two camera sensitivity sliders, one for side to side, one for up and down, like a lot of games do. So it's up to you how you want to go. I'm going to do the next test with my controller. You can try it out with your mouse and keyboard. It should work just fine. There we go. I can look up and down, look around, I can look towards the ground. It stops at 60. Stops at 60. There we go. Fully working first-person controller. Now, notice how the head isn't, the camera isn't right yet. So we've got to fix that. So that's the next thing. And then the controller itself is pretty much done from the movement aspect. Okay, so for the movement of the head to work, I could just directly open this up, go to the hips, go down there and parent the camera directly to the head. But I don't want to get the rotation from the head. I really just want to get the bobbing, so it kind of adds a certain amount of realism. So inside of here, I'm going to create an empty. Call this head position. And I'm going to open this up till I find the head bone, neck, head. I'm going to parent this to the head. I'm going to reset its position so it's at the top, and then I'm going to find the right place for where I want my head position to be, basically where my camera should be. So I'm going to put my camera somewhere, I don't know, over here maybe. I think should be good. There we go. So we're going to use this. This is now parented to the model's head. That's fine. I'm going to use that head position to drive the camera position. That's the idea. Okay, so we have to go back here at the bottom here. Let's go into the flow graph. I'm going to go into object and I'm going to create a variable called head position. So I'm going to move this towards near the camera stuff. So this camera, I'm going to put it underneath the camera ref here. Head position is going to be a transform. And I'm going to click over here and I'm going to search for head position. That that I created. Now, the reason I'm creating this is so I can move this around to get exactly where I want the camera to be. So I'm going to grab this, drag it in. And this we're doing on an update. And drag off this and say transform.position set. What are we setting? We're not setting the player's position, we're setting the camera. So we're going to grab the camera reference. So we're moving the camera to the position of that head position, not the whole character, because we're going to get some weird results. Some very, very weird results. Here's my head position. I'm going to drag off this, go transform.position, get, plug that into there, and that's pretty much it. So now the camera will follow that head position. The head position will follow where the actual head is. So we'll get some nice bobbing and some moving. So let's just put a comment group around this. Make this red again, like we did with the other red ones. And this one's going to be, let's call this camera follow head position. Okay, so let's see this again one more time. I'm going to select the camera so you can see what's going to happen. There is my camera. I can actually just move my camera down just to show you what happens. So actually, let's just zero the camera position out in all directions, just so you can see the camera's on the floor when I hit start. Notice how the camera is now where the head is. So if I run, notice how we're getting that really nice bobbing from the running, but we're not getting the rotation. The rotation is what causes it to be very, you can get some serious motion sickness. I'm not even joking. There we go. Fully functioning camera. The head is, it's following the head position. What's nice about this is I can adjust the head position to where I would like it to be. Sometimes it might not feel right. There we go. Works fine on the keyboard, and now I'm going to test it on the gamepad. There we go, it's working on the gamepad. Only problem is I don't like seeing the cursor when I'm playing the game. I don't hide that cursor. So let's do that, and we will be in a good place to continue with the rest of the stuff in the next phase. We will do the jumping in the next phase, and we will also do the ground check, which will lead us to being able to do a lot of other things. So, but let's just, you know, get rid of that cursor. Okay, so I'm going to go into my flow graph, and I'm going to create a custom event, because we're going to be able to, actually we'll just do it in the start for now. We'll move it to the custom event later. So at the start of the game, I'm going to want to first and foremost make the cursor invisible. So go cursor.visible, false, so it's going to be invisible. And then the next one is, if you're playing on, a lot of you have two monitors and you ever played a game where you're moving around first person, then you suddenly see your cursor popping up on the other screen, that's not what you want. So you're going to want to lock your cursor as well, so that your cursor stays within the bounds of the game view and not go into another screen while you're playing the game. So we're going to go cursor.lockState, and we're going to say it is locked, and that's it. So this here at the start, we're going to make this green, because green means it fires off and it's a healthy amount of firing. There we go. We're going to say disable cursor when the game starts. There we go. So we're going to disable the cursor when the game starts. So let's see how that goes. There's my cursor when I start the game. There we go. I have no cursor. Got some nice head bobbing coming from the animation itself. And that's it for this video. I hope this has been helpful. I know we've covered this before in previous videos. I just wanted you to not have to go to another video to watch this again, so I just put it into this one. Plus, this one allows for us to use our new input system that we are using for the movement and for the animation. So all of this is working quite nicely. I haven't had any issues so far. If I do run into any issues, or if we run into any issues, we'll solve that problem when the time comes. But up to this point, we got the input, we got the cursor to disable, we've got player movement, the Y rotation, and the X rotation. We also have the camera follow. So that is what we did in this video. In the next video, we're going to go and expand onto the controller. So we're going to add jumping, We'll have a ground check. We'll move on to wall running, that sort of thing. So until I see you next time, thank you so much for watching these videos, and keep safe, and I will see you soon. Cheers, everyone.